Assalamualaikum warahmatullahi wabarakatuh. My name is Ayuni Binti Ismail and welcome to my FRP1 presentation video. The title of this research is Study on Drilling and Blasting Tunneling Method at East Coast Rail Link ECRL Section 6. Next, we will proceed with research background. The ECRL project entails the full implementation of the railway infrastructure and system, which includes earthworks, bridges, tunnels, culverts, depots, and signaling and communication system. Same goes to ECRL Section 6. There are 21 tunnels will be constructed and some of them is already breakthrough. For instance, the new Austrian tunneling method, NATM, was employed in this construction of the tunnels. Based on the FATCA 2017, knowing the geotechnical aspect of the ground is crucial before beginning any building operation. In order to get a good picture of the ground condition, boreholes are dug at the necessary places to identify the potential excavation that could cause ground movements or have serious consequences while building a tunnel. However, in the event that any issues develop while the works are being built, geological structure and building method have an impact on the construction schedule. So, in this project, I will discuss on the geotechnical structure of the tunnel and the tunneling method while this tunnel is constructed. Next is problem statement and objective. For the problem statement, in the study, the focus is mainly on the Tunnel 21 ongoing construction along 824 meters in Kampung Paya Pasir, Maran, Pahang. There are a few obstacles that come up, such as settlement of the ground and heavy water flow. The rock formation that surround the tunnel contain a substantial number of faults, cracks, voids, and the developments of water ground, all of which contribute to the construction of this obstacle. The excavation work had to be put on pause for a short while because of the obstructions, and efforts were made to find a solution to the challenges that had been faced. The objective of this study is first is to study the geotechnical characteristic and construction method of the Tunnel 21 in ECRL Section 6. Second is to analyze the obstacle occurs during the construction of the Tunnel 21, and lastly to compare the construction timeline of the Tunnel 21 in ECRL Section 6. Next is scope of study. This study was carried out at Malaysia Rail Link MRL Section 6 in order to learn about the geotechnical characteristic and construction method that were utilized during the building of the Tunnel 21. Despite primarily focus on the construction of the earthwork, which includes the construction of the tunnels. The challenges that arose during the construction of Tunnel 21 that are relevant to the study are going to be analyzed as part of this study's research. As a direct consequence of this, it will be carried out by contrasting the respective construction schedule of Tunnel 21 and Tunnel 70. Next, we will proceed with literature review. First is geotechnical characteristic of the tunnel. In the context of the tunnel project, the formation of cracks, faults, and groundwater in front of the road face will play a significant part in ensuring that the road in the surrounding area is stable. By analyzing the image produced by the geological radar, grading and classification can be accomplished according to the structure plane, the degree to which fracture development has occurred, the amount of the groundwater presence, and the rock that is located in the surrounding area. And for the table above, the classification describe the complete and dense rock mass without fractures. For the classification 2, there are a few faults and fractures in rock mass. Classification 3, more faults of the rock mass in the surrounding area, and for the fault classification is many faults of the rock mass in the surrounding area, and last one is it's become a large number of faults of the rock mass. And the Q value can be determined by using the Q system, which is Q system is a description of the road mass stability of an underground hose in jointed road mass can be obtained by calculating its Q value. If the Q value are high, the stability of the system is good. If they low, the stability is bad. The Q value can be determined by the using following equation, which takes into account of a total of 6 parameters. The equation is Q equal to RQD over Kn plus Kr per Ka plus Cw per SRF. RQD refers to the degree of the jointing rock, which is rock quality designation. Jn means the joint set number, Kr joint roughness number, Ka joint alteration number, Cw means the joint water reduction factors, and lastly SRF, which is stress reduction factor. Next is cross-section method. The method that has been chosen is New Austrian Tunnel Method, which was created in Austria between 1957 and 1965. This method is a technique for building tunnels in the Alps. The major goals of developing NATM was to build tunnels with greater in-situ soil tension and deeper depths. The undercut tunnel has a curved wall composite lining structure with three main components. First, primary support, second, waterproof insulation layer, and lastly, secondary lining. While molded concrete is used for secondary lining, wet blasting technique is employed to the primary support. And the construction in NATM include the two-bench excavation method, three-bench excavation method, center cross diaphragm CRD method, and drill and blasting method. For the two-bench excavation method, this excavation technique is appropriate for the geological condition with value more than 1 and less than 10. In order to secure the stability of the surrounding area and prevent any collapse during the excavation process, the excavation will be divided into three portions, which is top heading, bench, and invert components. While for the three-bench excavation method, this excavation technique is appropriate for the geological condition, which is lower than 0.1. In order to maintain surrounding stability and prevent collapse during the excavation process, the excavation will be divided into four portions, which are top heading, middle bench, lower bench, and invert of the three-bench excavation method. For the center cross diaphragm CRD method, this CRD approach will be used for sections that have strong requirement for settlement management are surrounded by weak rock which is lower than 0.1, are deeply buried or cross below important structure. Upper left, upper right, middle right, low left, and low right make up the center cross diaphragm method. And lastly is drilling and blasting method. Drill and blasting tunneling method is a common method used in underground tunnel construction. It involves drilling a series of boreholes into the rock and then using explosive to break up or fragment the rock and create an excavation space. The fragmented rock is then removed, usually by mechanical means, and the excavation space is increased. This process is repeated until the desired tunnel size is achieved. The next topic in the literature review is challenges in tunneling construction. There are two challenges that have been covered in this project, which is settlement of the ground and heavy water flow. For the settlement of the ground settlement is the vertical movement of the ground which often produced by changes in tension inside the earth. This movement is characterized in geotechnical engineering as the vertical movement of the ground. Interim subsidence is frequently used to describe the caving in and sinking of the ground, which may or may not be connected with changes in the stress of the soil. An excessive amount of the settlement or subsidence can cause distortion and damage to structure, service, and infrastructure that are founded on the materials that is prone to movement. This can occur when the material is subjected to extreme in either direction. For the water flow, the intrusion of the groundwater into tunnels can be considered a possible risk and is also an important component that influences the rate at which tunnels are excavated. Controlling the amount of groundwater that seeps into tunnels is one of the challenges that engineers and builders must overcome. Tunnel underground inflow is the flow of groundwater into the tunnel from surrounding rock caused by hydrostatic pressure, seepage, or chemical infiltration. It can cause a range of issues, including water accumulation, structural failure, and reduced tunnel stability. We will proceed with the methodology. It will start by identifying the geotechnical characteristic of the 31 and proceed with identifying the tunnel construction method. After that, I will analyze the challenges in the tunnel construction, which is settlement of the ground and heavy water flow. And lastly, to end this project, I will compare the timeline of the drill and blasting work of the tunnel 21 and tunnel 17. Next is expected result. In tunnel building, the Q value and excavation method are both very significant factors to consider. This is due to the fact that both factors contribute to the formation of some existing difficulties and will cause delays in the construction of the tunnels. As a result, a tracking of progress is carried out to investigate the amount of time required for the breakthrough in tunnel 21, and this amount of the time will be contrasted with the amount of the time required for the breakthrough in tunnel 17. Due to the numerous challenges that arose during construction of tunnel 21, the amount of time required to be complete tunnel 21 construction was predictably more than that required for tunnel 17. And lastly, with the conclusion, this was done with the intention of analyzing the challenges that arose during the construction of the tunnel by taking into account a variety of parameters, such as a Q value and the manner of the tunnel's construction. The findings of the study, which were presented in the chapter that came before this one, demonstrate a connection between the variables that contribute to the appearance of obstacles and the obstacles themselves, which are responsible for the delay in the completion of the building activities. Performing a timeline analysis for the construction project will reveal this product. And I think that's all from me. Thank you.